how to use Twitch in the last 12 hours. So now we're back up and running. Stream is live and I can actually see the chat. So that's good. And I don't hear myself talking, which was going to drive me nuts. So last night we left off with adding some exception handling and message retie. We briefly mentioned the outbox. I think I'm definitely going to do a full episode on the outbox and how that works. One of the questions that came in, though, via direct messages on Twitter last night, or I guess early this morning, was how do I unit test? And I looked up and realized that in this project, I haven't created a single tests project or a unit test yet, which probably goes against a lot of tenets around solid principles and all that. So I thought what I would cover this morning in kind of the first kickoff session, which considering the rain outside that we have right now, and the fact that we're supposed to. Why can I never remember the request? What is it? Anyway, we're supposed to stay inside, or at least keep our distance from other people. So I'm doing that by sharing my experience with MassTransit and how to build stuff with it, and kind of answering questions as we go. So I'm going to go ahead and add a new test projects on here. So MassTransit does have some pretty extensive test support built in. So I'm going to create a sample.tests. And actually, let's give it a little name. Let's say sample.components.test, because what I want to test is I want to test my consumers and my sagas. I will make this a Netcore App 3.1 project, I think. No, it's a class library. Yeah, Netcore App 3.1 is fine. Doesn't matter. I don't think it matters if it's Net Standard or Netcore App. And I will add that to my repo. Now this, under the hood, JetBrains just does a .NET new on the project and uses the standard built-in templates. So one of the nice things about it. And now I have a class 1. Now, first I'm going to need to go manage some NuGet packages. I use NUnit. I know some people like to use XUnit, but this is what I use. And with .NET, we have to add a couple of different things. So we add NUnit, but we also have to add the NUnit test adapter, which makes the tests run in .NET Core. And then there's like one other thing we need, and I think it's called like Microsoft.test something, net test SDK. I think that has to be in there too. And those are the 3 dependencies I think you need to run projects in the test runner. So if you haven't used Rider before and you're stuck in Visual Studio World, the unit test runner in Rider is awesome. If you've used ReSharper in Visual Studio, you know what I'm talking about, but the unit test runner is probably one of my favorite features of the JetBrains toolset. When I tried to set this up in Visual Studio Code or even using the Test Explorer in Video Studio, I was just like, no, this ain't happening. It's horrible. I can't imagine being stuck with that. So I will say that's what it is. So now I am going to create an NUnit test fixture. I'm going to first create a unit test for the consumer that we created in the earlier series around submitting the order. So I'm going to say, and I tend to name my tests in kind of a behavior-driven design style or kind of an RSpec style. I started writing unit tests in the late 08s or 06s, whatever. 08 just sounds really cool. So I'm going to say like when an order request is consumed, and that's the name of my test fixture. The test result that I'm going to have is should respond with acceptance if okay. Sounds like a good start. All of our tests nowadays are going to be async task based because we're going to be awaiting and we're going to be using that type of capability. Now I'm going to rename this. So I'll call this submit order consumer specs because I want to have these tests on that. I'm going to also add a reference to my sample components project, which actually has the consumer in it. And that should bring in MassTransit for me because that project is dependent upon MassTransit. So MassTransit within the testing namespace has a test harness. So I'm going to create a harness equals new in-memory test harness. And the in-memory test harness, when we first started out in this series, I mentioned that, Mediator is in memory, but that MassTransit also has an in-memory transport. So for unit testing, I'm seeing some slowness on the video. It makes me concerned. I'm seeing reds and yellows. That's not good. So for in-memory testing, one of the things that I have is I have an in-memory test harness, which has an in-memory transport. It has in-memory Saga repositories, basically everything that you would want to test in memory, but get a full test of everything is part of the test harness. So when I create an in-memory test harness, I want to test my submit order consumer. Yeah, I saw it go red and got a blip and then came right back. So I don't know if I had a Wi-Fi issue or what. I'm on 5 gig and I have my own channel, so I should be good. And I have gig fiber, so, but again, everybody's home, so obviously internet usage is definitely screened up. So anyway, back to this. Thanks for that. I want to create a unit test for my consumer, and what I'm going to do is I'm going to send a request style message to it, and I'm going to expect that I get a response back. So I will get my consumer as a harness.consumer, and I'm going to do my submit order consumer. And I believe I have to pass a consumer factory because it does have some dependencies, or does it not? Looks like it does. What are my dependencies in here? Oh, I'm dependent upon that logger. That's fun because, loggers are a real pain. So it's just going to create more work for me. Or I could just take the logger out because all it does is a debug. What's my option here? I think my option is to go with save time. So I'm going to make an alternate version of this constructor. Oops, not going to do that though. And then I will just do this. So if I don't have a logger, I won't log, otherwise I will. Great. Problem solved, solution created. So I have a consumer, I have my harness. That's all I have to do to set this up. So this is going to create a bunch of things under the covers. At this point, I can call harness.start, and I'm going to await that because it returns a task. And because I'm using NUnit, I'm going to have I'm going to do a try finally. And I'm going to say await harness.stop. Because I want to stop that harness and kill any threads that are running, especially since NUnit tends to run a lot of stuff concurrently. And if things go sideways, I could still have stuff running in memory. It could hang some processes. So just trying to keep that legit. At this point, I want to send a request to that consumer. So I will await harness.input queue send endpoint dot send, and I'm going to say new. Oh, but I've got to give it a type. The type is the submit order command, and then I'm going to create that request. Again, I get my missing properties through my analyzer, which is all the awesomes. I will create my order ID and keep it around. Again, I use newid.nextGUID because that gives me a nice ordered sequential identifier. I use newid everywhere. I will use invar.timestamp to use the initializer variable. And my customer number, I will just make one up, which is 12345. Now, this is going to send to the consumer. And I now want to make some assertions on that consumer. So I want to say consumer.consumed select submit order dot any, and that should be true. Is true. So within the consumer test harness, the consumer keeps track of every message that is consumed. So it uses an observer and keeps track of all these different messages that are consumed. And what this will do is say, if the consumer received a submit order message and consumed it, it will return true. So very simple test. It does a very simple test here. Let's run that and see what happens. Keyboard shortcut, Command U, Command R to run the unit test. Okay, so I know that's pretty anticlimactic. It literally just said test was green, because aren't you supposed to write a test that fails and then make it pass? But again, TDD, it's, if I'd have started right, I might have gotten it right, but we're going to go with what we have. So this isn't really asserting everything that I need to know, because I didn't check to see if I got a response, because I don't have any response handler hooked up to this. So I'm also going to add another piece of code in here beforehand that says harness.connect request, create request client. Yeah, oh, that's the old one. Connect request client. I think that's what it is. Yeah, because remember, I'm sending a request and I want to respond with an acceptance. And I want to have the submit order, and I have to await that. So I am going to await harness.connect request client, and that is going to give me a request client for that submit order, just like my controller does. I know that the consumer consumes the message, so that's great. Maybe we'll save that for later. We'll dupe that one off into something else. And say should consume submit order commands. Great. But now we want to actually do the request and do the request against it. So we're going to say we're going to create the request client. Instead of calling input queue send endpoint send, we're going to say await request client dot get response. And the response we want is the order submission accepted. And we're going to send the exact same message type. And here we are going to send the request, we're going to await the response, and then we're going to assert that the consumer consumed that message. We are also going to assert that the consumer, not the consumer, but the harness dot sent the order submission accepted, because we want to verify that that was sent, although the response is going to verify that for us anyway. And we could do something like assert that response.message.order ID is equal to order ID. Now I'm actually sending the request. I expect to get a response. Because I'm using the request client, it's going to put the headers on to say that I should actually get the request back. And I will run that one. And it passed, which is really awesome. Now let's make it fail, because our failing case, because we want to verify that this actually works. So if I put the test in here, then remember it's going to say, okay, well, if you have test in the customer number, it's actually going to fail. So let's see if it actually fails. And again, this is just kind of going off the cuff here, see what happens. It's probably going to blow up or take a long time to run, because I didn't get the message that I expected back. Yeah, so it's going to sit here and it will probably run for 30 seconds, because again, our request timeout is 30 seconds and it will fail. Now we could make this fail faster by actually handling the other response, the order submission rejected. But that's not what we're really trying to test here. We're trying to test that if we send it with that, we should get the accepted. And we can see, yep, sure enough, as I expected, the timeout waiting for response happened. We can see where it happened. We get all the nice little call stack stuff. Great times. So we know that this works. We know that we're getting it accepted. Our test is passed, so we can kind of go through that. We're happy. But we do want to test the negative case. So let's go ahead and dupe this test again. We should say, should respond with rejected if, and we'll just say test. We'll create the customer number of test 123. We will actually try to get the rejected. And we should verify that we get that the message order ID matches, that they consumed it, and that they, again, I'll have to change this assertion because that isn't what it's going to send. It's going to send this. And now if I run all these tests, actually that one might not run, but we'll see. You can see it picked up all 3 tests in the assembly, and all 3 tests pass. So everything is great. If I go and I change my consumer's behavior to do something really bad, like accidentally put an X in here and rerun those tests, we'll see that I'll get a failure because this one's going to sit here and try to run, and it's going to keep waiting. Now I could code this test so it runs faster, so it doesn't hang my build. I could go change this test so it actually returned both versions of the message, checked both versions. But I'm not going to do that right now because I just don't really feel like it. This one is with the command. So here's an interesting thing that some people like to test. I'm not real big on, but it is good to do negative tests as well. So when I submit the order, this should not respond. So I want to make sure that when I call the order submission accepted or rejected is false. So what I want to find out in this case is when I submit the order, I want to make sure that none of the response messages are sent as part of this test because I don't want it sending garbage data out. So when I do a send and I don't include a request ID because I'm not using the request client, I want to make sure that it doesn't actually send any responses back. So when I run these tests, we'll see. And the reason we're seeing this take so long is because should consume submit order commands, when you say select any and you're expecting false, it's going to wait the full test timeout to do that. So by default with the test harness, timeouts are 30 seconds. And so that kind of makes the test kind of run long. If you know that these run pretty quick, you can reduce the timeout significantly to like 10 seconds. And that's something you can set in the harness. Again, that's just something that's going to be there, and we're going to probably end up sitting here for a minute because we're checking 2 of them, or we're finding out it doesn't work, one of the 2. But my guess is that we're going to see this complete, and eventually it should pass because neither of those messages were sent. That's why it's kind of hung right there. I'm not going to wait for this because I don't feel like it. I am going to change the harness timeout. I want to say that it's one of the parameters, or maybe it isn't. Let's see here, harness.test timeout equals time span dot from seconds, and let's just say 5. So we can pass a test timeout. And what happens if I run this now? Now I should get a lot quicker failure on those, or those methods should return a lot quicker. So I bet it'll be 10 seconds this time. Yeah, see, it took 10 seconds because it waited on each one, and each one of those has a timeout of the test timeout to verify that the messages are there. So now I have 3 unit tests. I'm testing my consumers. I didn't have to set up a transport. I'm not talking to RabbitMQ. I'm not doing any of that. I'm creating an in-memory bus that actually goes out and looks at the data and actually executes the methods against the consumer. So good times. Now, if I was going to say the consumer has one more piece of behavior that I'm not testing yet, and that is this publish. The fact that it publishes this order submitted message. So if I wanted to create a test for that, I could go back to my tests and I could say, let's just do this one. I don't need to test. This test doesn't need to be slow because I don't need to test this anymore. I have another test for that. So I should say, should publish order submitted event. Don't need this. And I want to do the send. I want to do the submit order. And I want to assert that harness.published.order submitted is true. So I want to verify that this message was published as part of the test. So now if I run that test, I will see that the order submitted event is published. And I could also add a test to say, and this one would actually probably be better to start from here since I need the timeout, but I should also take this title and say should not publish order submitted event when rejected. And the time span is here, the consumer is there. I'm going to send the submit order. I'm going to use the test 123. And I'm going to assert that this was not published in this case because I don't want the order submitted message published when I do that. Okay, so there's a question in the chat. You're just testing messages, but is there any reason to test the contents of message are as expected? I think if your consumer did any validation on that, which, theoretically it should, if an order doesn't have a customer number, it should reject it for that reason. And that's kind of the validation that should be in there. I made the validation pretty simple. I just said if customer number is test, then reject it. But consumers, if you don't have total control over all the people that send you inputs and you want to validate your input, it totally makes sense to check and see if you have the appropriate data in the message to complete the request. So when you think about best practices and kind of the things around messaging, if I had a web API front end that gets a model, it's a lot easier to validate that model there to ensure that there's like a 99.44% chance that that message is going to be, or that command is going to be executed successfully. If I don't have a customer, or I don't have a customer number, or there are no lines on the order, there isn't any point in submitting the order. It's going to reject, and I should throw that out with some model level validation at the ASP.NET API level. Once I create that message, I'm sending that command with all intentions of it passing. I should have done enough validation. Now, if that validation is hardcore, like, do they have a valid credit card number? There's in-memory tests that you can say, does it match an appropriate pattern? But the credit card may not have enough for an authorization. You definitely don't want to be doing authorizations in your web API. You want those to be done in either an event for processing the payment or through a routing slip activity that's going to go out and do payment assignment and get an authorization. So from a best practices perspective, you should really be validating that the message you're creating at the web API layer is a complete message. If you are trying to be thorough and make sure that your consumer has all the data it needs as well, you can add that same validation check in the consumer. It depends on what you want to do. I like to verify that I have the information because I don't like passing null around. I'm kind of excited for the nullable reference type support in C#8 and get that start to be more widely used, because I think it would make a lot of sense to be able to say, hey, these things can't be null. Of course, once you put a message on a wire and know that people can pass old data or pass, and that's another subject. But, if the consumer needs certain fields and they aren't there, it's probably best to then do that rejection type thing. Now, one of the things you could do is you could just throw like argument null exceptions. And when the consumer throws an exception, MassTransit is going to take and wrap that up in a fault message, which in the case of request response is going to send that fault back to the request client. So the request will get the exception and it will throw back. And when you're waiting on that, you'll be able to process that immediately. If there isn't a request, it publishes that fault. So it's really, the guidance I typically do is if you know that something can't be null, do those checks up front and then return some sort of, business level event, or just throw an exception. If you just want to throw an exception on the argument so that the request client says, hey, you did what's equivalent to a programming error. You didn't include an appropriate argument in the call, which if you think about a message, it's just a bunch of arguments, around that. Let's see here. What did Albert say? You're testing dial tone here. Yeah. If you need to test logic, make sure, yeah, that's true too. So If you know that your messages are well formed, checking them and actually doing unit tests against them, I don't like to think of that as necessary. And it comes down to, do I really want to unit test property getters, or do I want to unit test the behavior of the consumer? And that's what I tend to focus on, because when you do that, I'm getting message serialization. The in-memory transport serializes message using whatever serializer you've configured. So if you're using JSON, it serializes using JSON. If you're doing any sort of additional capabilities, it's all using a real message transport. It's just in memory, and it's actually modeled after RabbitMQ. So it has an in-memory fabric that has exchanges and queues that you can basically bind and connect up together. So I basically wrote an in-memory version of RabbitMQ for MassTransit to be able to test the message consumers and sagas. So I think that answers a couple of the questions. Definitely keep them coming, because they help kind of guide the conversation. I've done a test around the consumers. I wanted to also show how to test my Saga. So there's a Saga harness as well, and I'm going to jump into that next. So just like I have my submit over consumer specs, I'm going to add another class. And this is going to be my order state machine specs. Why do I call them specs? Seriously, it comes from our spec. It's a habit, and once you do it for as many years as I have, it's what you always do. Should initiate on submitting an order. I'm just giving it a name here. And I'm going to create a test. Should create a state instance. Thanks, Albert. Appreciate that. It's all about the specs. It's because I put a bunch of tests in one file. I don't do like one file per test. That would just probably drive me insane. I cut and pasted too much, of course. So I just wanted to steal some of the code that I already wrote, so I wasn't just sitting here doing this. If I was an awesome presenter, I would have like snippets prepared, but I literally thought of this like 30 minutes ago, so we're just going to roll with it. Harness dot state machine saga, order state machine, order state. And I need some arguments here. It probably wants, oh man, are those arguments backwards? That's going to annoy me. They are. Okay, all right. So if you remember from the earlier episodes, the order state machine is our state machine saga. It's written using Autonomous, and it has the handlers for the order submitted as well as the order status requested message. So the way our Saga works is we can actually, when the submit order consumer, oops, now I have two of those. When the submit order consumer receives a message, it publishes out an order submitted event. That order submitted event is used by the order state machine to actually create an instance of itself. So initially when the order is submitted, it creates an order state instance, which is an instance of the Saga. It's identified by the ID, in this case the order ID, and it copies some of that data off. So what we want to test now is that when that event is published, that our Saga instance actually gets created. So we're going to create our state machine harness. We're going to convert our method to async task, which, again, Writer does so much for like adding namespaces, changing types. I mean, it's quick fixes were like the inspiration for everything they did with the Roslyn IDE changes in Visual Studio. And so it's nice that all of those tools are available in every editor, but I will continue to promote JetBrains Writer because it's awesome. So I'm going to have an order ID. And in this case, I don't want to actually talk to the consumer because I've already tested the consumer. I have unit tests for that. Now I want to test the Saga. So I'm going to junk all this code because, again, I'm not testing the consumer. I'm testing the Saga. And in this case, I want to say harness.publish harness.bus.publish. And I'm going to publish the order submitted event. Again, passing new. I've got to await it. This is actually kind of fun. If you don't await it, .NET Core will tell you that because the call is not awaited, execution continues, whatever. But there's actually, the MassTransit analyzer is also coming and saying, hey, I publish endpoint publish is not awaited or captured and may result in message loss. Because if publish throws an exception, it could be telling you that your message was not published. So nice little feature there. We're going to add our missing properties. In this case, the ID is going to be our order ID. The timestamp is again going to be invar.timestamp. And our customer number, we know it can't be test, so we'll just do 1, 2, 3, 4, 5. So we're going to publish the order submitted, and we're going to expect that our Saga instance gets created with that order ID. So now we're going to say saga.created.contains. And our contains is going to have the Saga ID, which is in this case is our order ID. And what is that? Okay, contains order ID. Right. So var Saga instance equals harness.contains order ID. This might be right. I'm gonna have to remember here. I might have to call select on this. I can't remember. This is how my brain works. Select. Okay, so this is a filter. Because I think select has to be used here, but we're going to try this. X.correlation ID equals order ID. Yeah, so this one I think is the one we need to use, just like we did on the other one. Assert that .any is true. We'll start there and see what happens. So we're going to publish this message, and we're going to try to find out if we have a Saga that matches that order ID. Let's give that a shot. Oh, it worked. So I guess my brain is in place. So I know that there's a Saga in there now. Now I can say something like saga.sagas. But I want to know that it was created. So I want to know that it was a new instance. I'm going to pass it order ID. And then I'm going to say assert that instance is not null. See if that works. Yeah, that's the other thing too, is I mean, just the performance. I mean, rider loads like that. And yeah, can't say enough about rider. It's pretty awesome. I tried to use VS Code. I couldn't get into it. It wasn't working for me. And I want to assert that instance.current state is equal to I want my order state machine. So I'm going to need this. So when you create a state machine, it does have a bunch of local variables. It defines a few things on it. So we'll just create my state machine up here. And I want to say that this is equal to order state machine dot submitted as the state. And I want to check that it matches the name because we're storing it as a string. So that should be close enough. So now I want to build this and run that. It's running our test again. Should be, oh, look at that. Look at that. Oh, what do we got? We got an error. Expected submitted, but was null. Wonder why that is. Wonder why that is. Because it's null. I wonder if it's because it's creating it and it isn't processed yet. Okay, let's do the obvious dumb thing here just to make sure I'm not fighting a race condition so I don't spend everybody's time. So if I wait, does it fix itself? This is the fun about asynchronous tests. Yes, it fixes itself. So it is a race condition. I'm actually checking to see that it's in a certain state before it is in that state, which is annoying. So if I have the instance, so how can I change that? Yeah, Rider's like 150 bucks. I mean, it's cheap. I want to say it's 150 bucks for an individual, something like that. If I'm wrong, let me know, but you know, it's well worth the money. Now, I will admit, as a Microsoft MVP, I get the whole JetBrains suite for free, but I also own it as well. So I have 2 copies of it. Um, so what am I missing here? I want to do saga dot. Aha! Okay, see, I knew there were other methods in here that I didn't have going around. So I want to do saga.exists with order ID, and I want to say x dot submitted. Right, okay, see, I knew there were methods in there that I didn't remember. So I don't be using this. Basically, I want to assert that instance ID is not null. I want to verify that it's created. I want that test to pass. And then I also want to look at the instance. I want to find a saga that exists with the instance ID in that state. So now if I actually come in here and run against this, it should say, okay, not only do I have a saga that has that ID, but I have one in that state. And no way it completed that quickly. I just don't believe it. Let's run it again. I don't trust you. Yeah. Okay, so now we're actually testing and we're verifying that we do have the instance in that state. And the reason that this is useful is because I may be sending multiple messages to the Saga, and I want to be able to wait until it's in one state and then do it, send it another message just to assert, you know, the property values in that condition. So once I have the instance ID, I can actually go ahead and grab that out. I can say var instance equals saga.contains. This is where I can use the saga.contains, and we'll just do instance ID.value. Why not? What am I missing here? Oh, not saga. Yeah, sagas.contains. And then I will do assert that instance.customer number is equal to 1, 2, 3, 4, 5. I'll build that and run that. And I know that it's capturing my data. So there we have it. I've created a test project. I've created the consumer tests. I've created the state machine tests. I'm able to send events to my state machine. I'm able to verify that instances are created. I don't think my state machine actually publishes any events yet. We're going to get to that as we add some cool stuff to the state machine. Oh, we aren't testing our order status requested. Let's go do that. That will be fun. That sounds like a good time. Let's do that too. So we have the state machine that's created, and we have the instance being created. We also want it to be able to, because if we remember, let me see if I can find this here. When we refresh our service, when we create an order with the generate GUID, my favorite, always at the top level menu item. When I go to create an order, which I'm going to go right down here and do using the Swagger UI, and I would create it with 1, 2, 3, 4, 5, 5, whatever, and I execute that, I get my order back 202 accepted. I want to go back and I want to get the status of that order. So when I send that in, this actually sends a request to the Saga instance to find out the status of it. And boom, it returns 200, status is submitted. Well, I want to verify that that works. So I'm going to create a unit test for that as well. So I'm going to should create a state instance, should respond to status checks. So we have our order state machine. We go ahead and we create an order ID. We publish order submitted because we aren't testing the consumer. We verify that it's created and that it's in the state submitted. And now we are going to say harness.connect request client, and we're going to do the check order command. Yeah. So we're going to connect the request client to that. We're going to say var request client equals await. We will then do a var response equals await request client dot get response. We will call check order, but the response we're expecting is an order status. And we will new this up with the order ID. That will actually work, but it gets mad because it isn't case sensitive technically if you're using JSON, because it converts it all to camel case, but we'll get it working here. So we initialize that, we get the response, and then we want to assert that response.message.state is equal to order state machine dot submitted dot name. So what we just created is we want to respond to status checks. So after we create the order submitted, we verified that it's in the Saga repository, we're going to send a request to it with the request client that says check order. The order is going to, and that state machine is expected to respond with an order status response. Let's see if that runs. It should. We aren't doing anything we haven't tested manually with the UI at this point. And there it passes. So there's our test. There's our test against all the capabilities of our state machine. And if we wanted to assert the messages being sent, but because we've actually tested the tools we're using, we don't need to go and check like messages sent and received, because we know they're being received because the request client passes and it has the appropriate result. So there we have it. That's unit testing. That's the first episode of today. Depending on the weather, I may do a few more. I wrote some notes and kind of went over stuff. If there's things you want to see, definitely hit the chat, post on Twitter, jump in the Discord. As you know, my skill set improves and I'm able to do more of these, I'm hoping to be able to get the Discord voice chat in so that people can actually do like a live call-in show. So you can say, I've been watching for a day. It's my first call, first time caller, all that fun stuff. So, and I will eventually be putting a GitHub repo up with the state of the code as we go along. Obviously it will reach the end state once we get through this example, but thanks for joining in. The chat's great. Good to, definitely the love for Ryder, and we'll catch you on the next episode. Thanks, everyone.